Differentiation is one of the most important ideas in calculus, and all it really is, it represents the rate of change, so the rate at which something is changing. And in this video, I'm going to break it down step by step so you can understand it inside out from the basics, and we build that up in future videos to more complex ideas. Now, you will often see this notation that says dy over dx oftentimes when you come across differentiation, and you can also see this other variation of it, f prime of x. Both of them means the same thing, but for now I'm going to just zoom in on this one right here, dy dx. And what it means really, the d, it's talking about very small changes. So for the d, small changes. The y is essentially dealing with the function, so the y is the function that we're working with, and whereas the x is basically the variable. So we're going to look at how to differentiate common functions now. So as a general rule, let's say we have y equals x to the power of n. This is the format that we're going to use for differentiating these questions that we're going to look at. So you will see dy over dx, and that equals to n multiplied by x times n to the power of n minus 1. Now that looks complex, but as we go through, you will see exactly how this applies, and it's going to be fairly straightforward, so just stick with it. So say we have this question, y is equal to x squared. If we were to apply our rule, then what we would have is dy over dx is equal to, so we're going to use the power, which is 2, and multiply by the coefficient of x squared there, which is essentially 1. So we end up with 2 times x to the power of 2, and we're going to take 1 from the power. So what that leaves us with there is just 2x to the power of 1. You can just leave it as 2x. So that's all it is really for this case that we're looking at. Let's look at another one now. So say we have y equals 3x to the power of 4. Now again, it's the same structure that we're going to work with. We're going to use our dy dx. So let's do dy dx, and that's equal to, so we have to do 3 multiplied by 4, so 3 times 4, and then x to the power of 4, and we take 1 off the power. So this then would just leave us with 12x to the power of 3, and that's done. Now this same thing would apply if we have a series of terms. So let's say we have 5x to the power of 4 plus 2x squared and minus 7. Now I've introduced this one for a specific reason, because I'm going to use the question to get the subtle nuances with the rules. So we would still do our dy dx, and what's going to happen here is we're going to take each term, and the terms are separated by the plus or the minus. So that's a term there, that's a term there, and that's also a term. And what we're going to do is apply the rule to each of these terms. So we're going to do 4 times 5, so that's our power times the coefficient. So that leaves us with 20x, and we take 1 off the power, so that's just 3. Plus now 2 times 2, so that gives us 4, and we take 1 off the power. Now, whenever we have a constant, it's going to be just 0, and I'll just explain what that would look like if we were to do it. So here it looks as if there is no x, but the term for the x is actually x to the power of 0. And when we do 7 times 0, already that term is 0. So you don't have to write the 0 at the end, but just to emphasize what we're doing here. How about when our power is negative? So let's say we have y equals 4x to the power of 5, and we're taking 3x to the power of negative 2. Now the same rule will apply to this one. So we do our dy dx, that would be equal to, once again, 4 5s, same as before, so 20, and x, take 1 off the 5 to the power of 4. And what we have here is we have to see this as a negative 3. So we would have negative 3 times negative 2 there. And that's going to give us a plus 6. And when we take 1 of this 2, so what we have here is minus 2 there, and we're taking 1. So that's going to leave us with a negative 3. So to tidy this up, this is what our final answer would look like. Now in the next couple of videos, I'm going to build on this. So be sure to like this video, subscribe to the channel so you don't miss the future videos.